Inferential statistics, on the other hand, allow researchers to generalize to a population of individuals based on the information or the data that you collect from a sample of those individuals. And it also allows the researchers to assess whether the results obtained from the sample are the same as those that would have been found or calculated for the entire population. So the inferential statistics have a probabilistic nature. There are two hypotheses, null and alternative hypotheses. The null hypothesis represents a statistical tool important to conduct inferential test of significance, whereas the alternative hypothesis usually represents the research hypothesis that's related to the study. So if you have two different groups, a null hypothesis would be that there are no differences between the mean scores of the two groups. An alternative hypothesis would be that there is a difference between the mean scores of the two groups. So for example, if I'm looking at what's the impact of technology on 8th grade science students learning, right? So a null hypothesis would be that there is no difference between the control group and the experimental group for the 8th grade science students learning. An alternative hypothesis would be that there is a difference between the experimental group and the control group on the learning outcomes, right? When you're looking at relationships between variables, null hypothesis says that no relationship exists between the variables being studied, whereas an alternative hypothesis states that there is a relationship that exists between the variables that are being studied. You accept a null hypothesis when the difference between the group is too small to attribute it to anything but chance, that it was not statistically significant, or the relationship between the two variables is too small to attribute anything but chance. You reject the null hypothesis when the difference between the two groups, control or the experimental group, is so large that it can be attributed to something other than chance. For example, the experimental treatment. In our case, it would be the technology. And the same for relationship, that the relationship between the variables is so large that it can be attributed to something other than chance, that a true relationship actually exists between those variable and it just didn't happen by chance. Statistical analysis are conducted to help decide whether to accept or reject a null hypothesis. You use specific tests in specific situations based on the number you have in samples and what statistics you're interested in. To alpha level, which is an established probability level which serves as a criterion to determine whether to accept a null or reject a null hypothesis. So the common levels that are used is 0.01 or 1%, 0.05 that you're willing to accept, 95% confidence in your results, or 10%, 0.10. If you set alpha level too low, say 0.01, you're most likely to commit a type 2 error, where you declare that there is no relationship when in fact there is a relationship. If you set the alpha level too high, say 0.10, you're more likely to commit a type 1 error, where you declare that there is a relationship when in fact there is no relationship. So you have to set the alpha level according to the type of error you wish to control, type 1 or type 2 error. Typically, 0.05 is very commonly used in education. So jumping to type 1 and type 2 errors, a correct decision is when the null hypothesis is true and you accept it, and or the null hypothesis is false and it is rejected. However, incorrect decisions are type 1 error, where you reject a null hypothesis when it is actually true. So for example, there is no difference between the mean scores of the two groups, but you reject it. A type 2 error is when you accept a null hypothesis when it is false. So there is a relationship or difference between the mean scores of the groups, but you reject it. You're saying there is no difference, right? So there is a reciprocal relationship between type 1 and type 2 error. as if you want to, if you control for type 1 error, likelihood of type 2 error increases. Again, as the alpha level becomes smaller, there is less chance of a type 1 error, right? But your chances of a type 2 error increases. And there are one-tailed and two-tailed tests. So one-tailed tests where you have an anticipated outcome in a specific direction, that your treatment or experimental group is significantly higher than the control group, or treatment group is significantly lower than that control group. A two-tailed test is done when the anticipated outcome is not directional. So treatment and control group will have a difference, but you don't know which direction.